Hello and welcome to our next session on decision science. Today we are going to solve some problems based on linear programming. Linear programming is a deterministic model in decision science. This is an optimization technique whereby we consider a given business problem and identify the variables concerning the problem. These variables are then used to write down the objective function and the constraints for the given problem situation. Under linear programming problems, both these are expressed using a linear relationship only. After the formulation of the given problem, there are two techniques that can be used to solve and resolve the problem. The two techniques are graphical method and the simplex method. The problem formulation is the most critical step in linear programming model. To begin with, I have taken one example of a company which produces three products A, B and C, which goes through three departments: drill, lathe and assembly. The hours of department time required by each of the products, the hours available in each of the departments and the profit contribution of each of the products are given in the following table. So this is my table which gives me the details of the three products A, B and C. This is the time required per unit in hours. And this is your three departments: drill, lathe and assembly, whereas we have the profit given per unit here, and we also have the hours available for each department. Clear? Now the marketing department of the company indicates that the sales potential for products A, B is unlimited. So we have a condition here, a constraint here. But for C, it is not more than 30 units. Determine optimum production schedule. So using this problem given to us, we are going to go ahead and solve it. So the first step is to come up with the objective function. Clear? So I will start with the solution here. Now the first step is assigning the variables. So let us write some variables. My decision variables for this problem will be, let us say we have a small x, which is number of units of product A produced. We will take y as my next decision variable for the number of products or number of units for the product B produced, and z as number of product for C produced. So now we have three decisions variable x, y and z. Let us go ahead and write the objective function. Now what is my objective here? My objective is to maximize my profit. Because you can see here we have been given the profit per unit. So I have to write a linear function such that it maximizes my total profit. So what is the profit for product A? 9. So this will become 9x. Okay, x is nothing but your number of units of product A, plus 15y plus 20z. So this will be 15y plus 20z. Fine. So this is my function. It has to be, must be maximized. Okay. So this linear function should be maximized. If you want, you can also write it like this: z max, it's a capital one, and this z is different. We have 9x plus 15y plus 20z. Fine. So this becomes my objective function. Then comes your constraints, which is my third step, finding the constraints. Now, what are the different types of constraints? First of all, this simple time constraints are given, but for each department, I'll have a different equation or a function. Okay. So for drill, I'll write here A, drill. What is my constraint for drill? For product A, we have only 3 hours. Okay. For B, it is 6 hours, and for C, it is 7 hours. Whereas the maximum hours available is 210. So for drill, I can write here 3x plus 6y plus 7z. And what is the maximum hour available? 210. So because it is maximum, this equation can be less, but it cannot go beyond 210. So we have less than equal to 210. Okay. Less than equal to sign is very important, because this is the maximum value or maximum hours which is available. The second constraint is for length. So again, referring to this table here, 3x plus 5y plus 4z. So we have here 3x plus 5y plus 4z. Again, it is maximum less than equal to 240 hours. Okay. C for assembly. Now for assembly, we have 8x, 10y and 12z. So 8x plus 10y plus 12z is less than equal to 260. Okay. If you want, you can reduce this further while writing the final answer. Fine. Now, after reading this paragraph, you will find there is one more constraint. Okay. What it says? The marketing department of the company indicates that the sales potential for product A and B is unlimited. So there is no constraint for A and B, but for C it is not more than 30 units. That means we have a constraint on sales as well. So there is one more sales constraint. Sales of, you can say, product C. So here we have, because it is only for C, C is Z. So Z is less than equal to 30. It cannot be more than 30 units. Okay. So this is my final answer. So let us write the LPP. Therefore, your LPP formula or format is maximize my profit. So So let us write profit P. Okay, here if you want, you can also write Z max or P max, whichever you feel, you can do it. So here I am not going to write this step here, no need of writing this. I will write maximize P equal to 9x plus 15y plus 20z. Subject to what? Subject to some few constraints. Subject to, there are 4 constraints which we came up with. For drill it was 3x plus 6y plus 7z is less than equal to 210. Then 3x plus 5y plus 4z less than equal to 240. 8x plus 10y plus 12z less than equal to 260, and the sales constraint for product C, that is Z, is less than equal to 30. Okay. Now this is the maximization or the objective function. This is my constraint. Now apart from all these regular constraints which are given to you, there is one more constraint which says that your variable x, y and z should be greater than equal to 0. This is known as your non-negativity condition or non-negativity constraint. Okay, this completes my whole LPP problem. We can use this linear equations to solve the problem using the graphical method and find the values of x, y and z such that the profit is maximum and it also follows all these constraints. Okay. Later on we will see how to use the graphical method to solve this problem and find the final and the optimum solution. Okay. I hope you have understood. It was a very simple example. Please go through it once again and try to understand each step. Thank you.